Alright, so in this video we will summarize the important concepts of simple harmonic motion, okay, things that are going to be useful. So the first most important thing is that we say that if you can show that the acceleration, okay, for the object, for whatever thing that is moving, is in this form, minus omega square x, okay, where omega is a constant. That's it. We just write it in this manner. Okay, all this is a constant. So if the acceleration is dependent on the position linearly, then we know that the motion will be simple harmonic. So if a equals all this, then we know that the motion is simple harmonic motion. Okay, so the object will move such that its position with respect to time can be represented as a cosine function or a sine function and all that. Now, this allows us a few things. First of which is that we can then write that x will be equal to a cosine of omega t plus phi. Okay, where the a is simply the amplitude. So this is the amplitude. Okay, and it happens to be the highest value that the position can take. Okay, omega is something called the angular frequency, and we know that it is related to the actual frequency and time period. Okay, and we know that omega is equal to 2 pi times f. Okay, which is also equal to 2 pi divided by t. And this tells us that t is 2 pi over omega, or f is equal to omega over 2 pi. So all this is consistent with all the stuff that we've done. We also showed that if x is in this form, then v happens to be equal to minus a times omega times, not cosine, it will be sine omega t plus phi. Okay, now this a times omega happens to be the maximum speed. Okay, the maximum speed that the object can have, and we know that this will happen at equilibrium. Okay, wherever the equilibrium position is, this is when the speed is going to be the highest. So at equilibrium. We also know that the acceleration is negative a omega square and cosine omega t plus phi. This a times omega square is the maximum acceleration. Okay, and what we know is this happens at the ends. Okay, wherever a is the highest is where it happens. Wherever x is the highest is where this happens, because we know that a is actually equal to negative omega square times x. So if x is highest, then a will be highest, and that's what we notice in this. Alright, so keep all these things in mind. This is very important. You understand this, you'll be able to apply this. Now again, it all starts with this equation, if a is equal to negative omega square x. Alright, so now if we were to take all the stuff that we've learned for a mass spring system, okay, so for a mass spring, okay, that behaves like, you know, for a mass Hooke's law spring system, alright, whether the mass is horizontal, whether the system is horizontal, or whether it is vertical. Even when it is vertical, we have basically the same thing going on. Okay, it'll oscillate about the equilibrium position. It's just that when it's vertical, the equilibrium position is not the unstretched position of the spring. It'll be wherever the system comes to equilibrium if you allow this mass to come to rest. Okay, and in pretty much both these cases, we can reduce the equation to some sort of this. Okay, where a is equal to negative kx over m. So ma is equal to negative kx, and this basically comes from the fact that f is equal to negative kx, but f itself is ma, so a is negative k over m times x. Okay, so now if you look at this equation, okay, compare with a equals negative omega square x. Okay, and what do you see? If there's a negative omega, the omega square is equal to k over m. So what you already know directly by comparison, you know that omega square is k over m. Okay, so this implies that omega is square root of k over m. Right away we know this. And now once you know this, everything in the problem is very simple. So now I can write my x as a, as it changes its position. X will happen to be a cosine of square root k over m times t plus some initial phase phi. Okay, so that's very simple. V is equal to negative a times square root k over m times sine of square root k over m t plus phi. So now the maximum value for V happens to be a times square root k over m, and the acceleration is negative a times k over m, which is what we expect, times cosine of square root k over m times t plus phi. Okay, and the maximum value the acceleration can take is this. Okay, so all this can be simply written down, because as soon as you know that the behavior is in this manner, a times negative k x over m, the rest of the stuff follows. Okay, so that's what we have. Now we can also make conclusions if you're given the position, if you're given all the information for, say, the position as a function of time. From that also you can derive a lot of information. For example, let's say that you're given that x as a function of time is equal to say 4 times cosine of 3t plus 30 degrees. Okay, and that 30 degrees, let's put this as pi over 3. Okay, so this is the information that is given. Okay, we can obtain a lot of information from this equation. Okay, we can ask, first of all, we can ask what is the time period. So first, okay, what is the time period? Okay, we can also ask what is the frequency. Okay, or the frequency, time period of the frequency. Okay, so pause at this moment and see if you can answer this question. Okay, this is a typical multiple choice situation that you will have. So what is the time period or what is the frequency? So pause. Now I'm assuming that you paused, and I'm going to move on, and just pause here and then check your answer. Alright, so if I were to compare, what I'll do is I'll compare this with x equals a cosine omega t plus phi. If I compare it with this, you see that omega is equal to 3. Once I know omega, my time period I know is 2 pi divided by omega, so it is 2 pi divided by 3. My frequency is simply the 1 divided by time period, so it is 3 over 2 pi. So I can write this very easily. Okay, another question I can ask is, what is the maximum speed? Okay, again pause, think about it, and see what you get. Alright, I'll write the answer here. We know that V is equal to negative a omega sine omega t plus phi, which happens to be equal to negative a in this problem is 4, times omega, which happens to be 3, times sine of 3t plus phi. Okay, so V max is simply equal to 12 meters per second. So we get that. We can also ask maximum acceleration. Okay, once again pause and see if you can answer this. I'll move on with the answer. A is negative a omega square cosine omega t plus phi. In our case, a of t will be negative 4 times 9 times cosine of 3t plus phi, because omega is 3, square of 3 is 9, and so a max is going to be equal to 36 meters per second square. Alright, so a lot of information can be derived, can be obtained out of just knowing this initial start. You know the starting point, a lot of things can be given. And at the same time, if you know how the motion is already, the x, if you know that it's simple harmonic motion, if you're given this equation, then again we can obtain a lot of information from this. Alright, so in the next video we'll now look at some more examples of this and also start looking at the simple pendulum.